All right, we have one section left, which is the definition of inverse trig functions and their graphs. Their graph is not important except for arctangent. We'll just briefly introduce them. Okay, but let's first talk about inverse trigonometric functions. We have done this before. We know it's sine inverse x if we have a triangle, or for any angles. So remember what we did before. We say, hey, sine inverse 1/2. Let's say, if sine pi over 6 is 1/2, then pi over 6 equals sine inverse 1/2. That's what we had before. But then, suddenly we realize there's a problem. The problem is, if you know the sine value of some function, let's say, if you know the sine value of some angle, now by unit circle, this will give you the sine value, but then automatically you know, here, 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 they all give you the same sine value. Okay, if this one have a sine of 1/2, all these four angles will give you exactly the same sine value 1/2. Now if you put in the sign, positive, positive, negative, negative, these two will give you negative 1/2, so you can exclude them out. But still you have two choices. Okay, that's when we start to say, oh, this one cannot be done unless you restrict the domain for sine. And the domain we had was negative pi over 2 to pi over 2. Otherwise you have two possible answers within one cycle. Not to mention if you plus a 2 and pi, you will have more and more answers. But if we restrict everything to be from negative pi over 2 to pi over 2, we only have one answer. Therefore, we know which answer we are referring to. That's what we had before. Same thing with cosine inverse, tangent inverse, and all the rest. Okay. Now, we redefine the sine function. We can redefine this. But of course, we should have the same conclusion. We should still see this interval showing up somewhere. So now let's think about it. The first one is sine x. Knowing a x, you can find the corresponding y. Now what we want to do is knowing a y. We want to find the corresponding x. So we want to find the inverse function. From here you can see it's not doable. Why? The reason is because this one does not pass the horizontal line test. What we mean is, if you have a function you want to find the inverse, you have to draw a horizontal line and make sure that this function intersects this horizontal line at only one point. So if you know this is the y value, which is 1/2, you will know, okay, I'm referring to this x for my inverse. But now you can see you have multiple answers. Because this one repeats forever, you actually have infinite many answers. You just keep having more and more x, which will give you the same y all the time. That is an alert to tell you that you cannot have an inverse function if you just include all the possible angles. You have to restrict your domain. So how do you restrict your domain again? Now think about it. Number one, you should include all the possible values from here and here. If you just only include this part, you will lose all the negative values. So that's certainly not clever. Second, if you include everything from here to here, or maybe from here to here, you need to also make sure that you include them for only once. For example, if you pick your domain to be like that, which does include all the possible values, but the problem is the value here and here repeats, the value here and here repeats. So for the same y, the same height, you have two same x. With these two things in mind, now you know you have to be really careful. Number one, you have to touch everything from -1 to 1. So you need to include the peak. You need to include the peak and the bottom for sure. Second, you cannot go a little bit beyond that. You cannot go beyond that because then you have to repeat your value which make your function not invertible. With these two in mind, now you can see the clever way is try to include exactly half the graph, which has a length of pi. If you have a whole thing of 2 pi, you definitely repeat your values. Now it's just a matter of which half do you want to include. You can do this one, you can do this one, you can do this one, you can even do something in between, as long as you make sure that thing doesn't, oh, actually, this one's not working. You have to include the peak. Okay? With that in mind, you go to this graph, you just pick 1/2, going from one peak to one valley. You can pick whichever one you want. And we chose to pick everything from here to here, because this one stay close to the origin. Meanwhile, we prefer something positive compared to something which is decreasing. All right. So with that in mind, we take out this part. We have the graph we are trying to invert. Not the whole sine x, but only from here to here. And you can see that is going to be y equals sine x which is exactly the restriction we had before, to make sure we don't repeat anything, but we do include all the possible values. And then we have the inverse function, y equals sine inverse x, where your y is between here and here. Then if I'm looking for sine inverse 1/2, you will know I'm talking about pi over 6, not 5 pi over 6, not pi over 6 plus 2 pi, even though they all have the same sine value 1/2, only pi over 6. Okay, so that will be the first one of our inverse function. Technically, y equals sine inverse x is the inverse function of this with this restriction. So it is not the inverse function of sine x, because sine x does not have an inverse. But sine x with its domain restricted has the inverse function. Okay, they are different functions. This function here and this functions here, they are different. So make sure that every time you write down y equals sine inverse x, you are not trying to find the inverse function of sine x. You are trying to find the inverse function of part of the sine x. All right. That's the first definition. Okay. Now what's the graph of the sine inverse function? I guess that's pretty easy to write down. So let's write down all the properties we know. Domain. Okay. Here. Sine x, sine inverse x. Now remember, we have to restrict it. So for domain, it's this. Okay. Range, it's this. Because we know sine is between -1 and 1. Therefore, for inverse function, we switch them. The domain is from here to here, and the range is from here to here. Finally, we have the graph. This one has a graph going like that. Then this one should have the same one but flipped with respect to y equal x, the 45 degree, remember? So try that by yourself. You will find it's the thing look like this after the flip. Moreover, This is pi over 2. This is 1. This is negative 1. And this is negative pi over 2. All right. For the graph, that's the most you need to know, and we probably won't test it or even care about it for the graphs. For sine inverse, it's the same trick. You just need to know how to calculate the values. For example, sine inverse square root of 3 over 3 is going to be pi over 2, pi over 3. Sine inverse 0 is going to be 0. Sine inverse 1 equals pi over 2. Sine inverse negative square root of 2 over 2 is going to be pi over 4 with a negative because we're taking this one. Technically 7 pi over 4 also works, but we don't do that. Okay. Finally, sine inverse 3 does not exist. The reason is because this number has to be between negative 1 and 1. Okay, so the key is still try to find the values. We really don't care too much about the graph, but if you want to know it, this will be what you have. Okay, similarly, let's do the cosine inverse. Same logic. Okay. We still have more, but technically we want the one stays closest to the origin. You don't want a domain to be like, I don't know, 100 pi to 110 pi, things like that. You want that number to be small. Therefore, you have to be very close to the origin. So you only have two choices. You either pick this one, or you pick this one. Now, if you think about it, we probably prefer something which is positive in terms of angles. I really don't want to see some positive cosine values, but actually I refer to some negative angles here. Then, this leaves you only one choice, going from here to here. You include all the possible values from negative 1 to 1, meanwhile only for once. You go a little bit further, this thing starts to repeat, so don't do that. Therefore, cosine inverse, we can define it. The domain, we want it to be from 0 to pi. Therefore, the range of the inverse function is going to be from 0 to pi. Now for cosine, it's between negative 1 and 1. Therefore, it's between negative 1 and 1 in the domain of the inverse. For the graph, zero, pi, negative 1, 1. Therefore, if you flip it, it should be from it should be from 0 to pi. Remember, your x become your y become your x. Okay. Finally, let's think about how to draw it. At pi, it's negative 1. That's what you have. Okay, remember, this one goes like that, therefore this one goes like that, because you flip it. That's the graph of this. So a quick example, cosine inverse negative 1, which is going to be pi, and cosine inverse negative 1/2, which should give you pi over 3, remember? But now if you think about it, it actually should be 2 pi over 3. This one give you positive 1/2, but this one give you negative 1/2. Okay, so that's how you know if this is pi over 3 to give you 1/2. This is pi over 3. Therefore, the whole thing here is 2 pi over 3. Okay, again, get familiar with that. The graph, not so important. Okay. Now for this one, the graph is really important. You will see it a lot in the further classes, especially calculus. Okay, but same logic. Now see the advantage of knowing the graph. Now you want to pick a complete set of value. Meanwhile, you don't want to repeat. So of course, this one cycle will be good enough. Anything other than that will be redundant. Meanwhile, this one includes all the possible values you can have. So of course, we have tangent x, tangent inverse x, domain, anything but x cannot be no. We are already doing this, so note the difference. For sine, you have brackets, which means negative pi over 2 and pi over 2 is qualified. For this one, they're undefined. So you can only have parentheses, say not including pi over 2. For the range, therefore, finally for the graph, we have all the possible ones, but we only include one branch. Now think about how to draw this. Okay. Number 1, your range is from negative infinity to infinity. Therefore, your domain is from negative infinity to infinity. Number 2, your domain is from negative pi to pi. Therefore, your range is from negative pi to pi over 2 to pi over 2. Number 3, your vertical asymptote become your horizontal asymptote. So I do want to mention here, that is, has 2 horizontal asymptote. That is, and this is at negative infinity, this is at infinity. This graph is very important, so make sure you know it, and you will see it again and again and again in calculus. It does have a lot of nice properties. All right, so this is basically something we had before, but we revisited. Okay, the key part are the following. Number 1, you still need to understand why do we restrict the domain. Before we draw the unit circle, we draw the quadrants. This time we draw the graph. Either way, you have the same answer. Make sure you know the domain for each, the domain for cosine inverse, and the domain for tangent. For secant, cosecant, and cotangent, you follow exactly the same argument, and you also know the graphs of secant, cosecant, and cotangent from last section. I will challenge you to do it yourself. So, exercise. Find 2 things. Number 1, the domain restriction. Number 2, find the graph. Of course, based on the original functions of cotangent x secant inverse x and cosecant inverse x. Okay, try that yourself. Again, if you're trying to find the value of this, even though we have known the graph, I would say still, for now, we still do the old trick. We convert it to cosine inverse, which is easier to think about. Okay, so just do this graphs for once, but technically we won't use it. All right. That will be everything we need to know about sine cosine inverse. Now, some exercises. The first part will be some exercise we have done before. Okay, what is sine cosine inverse? 1/2. Let's do 1/3. Okay, now if you try to recall, what we do is, for things like this is complicated, we need to be very careful about what is an angle and what is an ratio. Usually we assign the cosine inverse or sine inverse to be an angle. Then this implies two things. That means cosine theta is 1/3. That's why theta is the angle. Number two, because it's cosine inverse, we know theta has to satisfy this restriction. Now our job is try to find sine. Okay, this is something old we had done before, so I will just do it quickly. If cosine theta is 1/3, sine squared theta, which is 1 minus cosine squared theta. Therefore, sine theta equals plus or minus finally, using this 0 to pi restriction, we know we should take the one which is positive. The reason is because theta is in this region. Okay, so that's what we had before. The still same thing holds. Now we have something more interesting. How do you solve this? Oh, hold on. If you think about it, this is very easy. You have some function, then you do the inverse of the some function using the property. This one should be at pi over 3. It's like do the sine and then do the sine inverse equals doing nothing, which is correct. Great. But what about this? And do you see the problem? Is this one 2 pi over 3? Number one, wrong. Why? Because no matter what, no matter how I did the calculation, I do remember one thing. That is, my theta has to be between this and that. That is my restriction for sine inverse. And this one clearly is bigger than pi over 2. So can't be this. Then, how do we do it? Now use the same trick. We want to know what are we talking about, the ratio or the angle? And for angle, we always assign the one with the inverse. This tells you, again, two things. Sine theta equals this, whatever that is. Number two, because it's sine inverse. So what you're doing is, you are looking for a theta in this region, which has the same sine value as 2 pi over 3. Okay. Once you have this set up, it's pretty clear. Who has the same sine value as 2 pi over 3? That will be this one, and this one. They all share the same sine value. Okay. Moreover, for sine, from here you can see the angle you're looking for is this one. Because this one, even though it gives you the same sine value as 2 pi over 3, in terms of value, it does give you a negative one. So our job becomes what? Find this angle. Through that, you can see theta equals pi over 3. Therefore, this one is pi over 3. So basically what you're asking is which angle which belongs to the region, the interval, the domain, the range of my sine inverse that can produce the same sine value as 2 pi over 3 does. And the answer is pi over 3. One more example to let you get a feeling about this. Okay, if it's hard to think about, write this down. If you're quick on that, you can skip all this. But for now, I will just do it. Then what you know is, number 1, theta belongs to here because it's cosine inverse. Second, cosine theta is the same as cosine 7 pi over 4. Okay, you want some angle which belongs to here that produce the same cosine value as this. For cosine, then we see this will be the angle you're looking for, and that should be pi over 4. Okay, so that's one more type of problems we can solve which we cannot do before. All right, that's all we have for this section. So one new type of problem and the definition of 3 trig inverse functions as well as their graphs. Again,